In this lecture, you are going to learn about major air pollutants, their effects on human health, and their sources. So first of all, there are 6 major air pollutants monitored by the US EPA. These are pollutants that have known impacts on human health, and so it was determined that they should be monitored and attempts should be made to limit the concentrations of these chemicals in the atmosphere. So the first major air pollutant that we're going to discuss is carbon monoxide. This is usually a problem if it's high indoor. So in that case, the carbon monoxide will actually outcompete oxygen and get to your red blood cells before oxygen can, which effectively suffocates you and can lead to death. Outside, this usually isn't as big of a problem. However, under certain environmental conditions and in cities, outdoor carbon monoxide can get to be too high. And the big thing that happens at that point is effects on the heart. And so people, especially people who already have heart conditions, can be severely affected by high atmospheric carbon monoxide levels. The second pollutant monitored by the EPA is particulate matter. If you take a look over on the right here, you can see PM10 and PM2.5. So, and then there's PM at 2.5, 24 hour, so annual versus 24 hour. So particulate matter is classified based on its size. So PM10 is larger than PM2.5. The smaller particulate matter is actually more harmful to humans because it can get deep into the lungs and sometimes can even pass over into the bloodstream. And so then you'd have chemicals in the bloodstream that can lead to additional health effects. The major health effect of particulate matter is respiratory problems, and it affects people with asthma and chronic obstructive pulmonary disease, COPD, mostly. The next pollutant is nitrogen oxide. Nitrogen oxide also can contribute to respiratory problems, and as we'll see later, nitrogen oxide can bind with water in the atmosphere to lead to acid rain. Sulfur dioxide is similar to nitrogen oxide in that it can cause respiratory problems. It can also lead to acid rain, but sulfur dioxide can also be converted to a variety of other sulfur-containing compounds that can lead to other health effects. So sulfur dioxide is an especially dangerous air pollutant because of the secondary effects that it can have. Lead is the 5th air pollutant monitored by the EPA. Lead is actually a bioaccumulating chemical. So that means that it can accumulate in your tissues. And so it sticks around in the environment for a long time. So lead also is a neurotoxin and so can cause detrimental effects to the nervous system. For this reason, lead is often monitored in children to make sure that we keep that there aren't high levels in children, leading to long-term neurological effects. And then finally, ground level ozone is the 6th major pollutant monitored by the EPA. Ground level ozone is actually created by combinations of these other compounds and sunlight, and we'll talk about this a little bit later on. Ground level ozone is different than the ozone found in the ozone layer, which will also be explained later on. And it is a major component of smog and again has major respiratory effects. So one thing that I want to point out is the sources of a lot of these major air pollutants, and this figure comes from the EPA. Ammonia is included because it contributes to particulate matter, so that's why that's on here. Here's carbon monoxide, lead, nitrogen oxides, particulate matter, sulfur dioxides, and ozone isn't on here again because it is a combination of these, but they have included another class of compounds called volatile organic compounds. This is a lot of different chemicals thrown into one category, and these also have harmful human effects. One thing that I want to point out here is the major sources of these things. So notice carbon monoxide, lead, and nitrogen oxides. Their major source, this bright blue color, is listed as mobile, so that really is also transportation. And as we know, the major fuel for transportation is burning of fossil fuels. Also, if you take a look at this light blue color, which is also a fairly big contributor to these three things, fuel combustion. Again, we're talking fossil fuels. So fossil fuels are burning is a major contributor to carbon monoxide, lead, and nitrogen oxides in the atmosphere, as well as sulfur dioxide that we see here down here. Fuel combustion is the major source for sulfur dioxide. Agriculture is another important source of major air pollutants. We see that agriculture is one source, not the major source, but one source of particulate matter, and it's the major source of ammonia, which contributes to particulate matter. The other major source is dust, and that's largely from construction. But it's important to keep in mind that fossil fuel burning does contribute to all of these things. That other thing that I want to point out here, particulate matter, here fuel combustion, and also mobile or transportation, those are sources of particulate matter as well, largely the soot that comes from burning fossil fuels. In addition to those 6 major air pollutants that the EPA monitors, they also monitor 187 hazardous air pollutants. So these pollutants are even more detrimental. They're typically, thank goodness, are found in smaller quantities. However, they are known to cause extreme human health effects like cancer. So another thing I want to point out about these toxic air pollutants or hazardous air pollutants is their source. So notice almost 50% of those toxic air pollutants come from the generation of electricity. Again, that's coming largely from coal-fired power plants where we get most of our products, most of our electricity. So I'm pointing out fossil fuel burning as a major source of air pollution on purpose. You just spent several weeks learning about climate change and the effects of fossil fuels on climate change. And then you also learned about non-renewable and renewable energy sources. And I want to make it very clear that burning fossil fuels is not just a contributor to climate change, it also leads to these major air pollutants and major hazardous air pollutants in the United States. So switching to renewable energy sources will also allow us to have lower air pollution. So I've pointed out that major effects of air pollutants include respiratory effects and some heart health effects. There are also some secondary effects of pollutants. So those include acid rain, ozone depletion, and smog. And we're going to spend a few minutes explaining each of those. So first of all, acid rain occurs when nitrous oxides or sulfur dioxide combine with water in the atmosphere, and they form acids. The result of that then is precipitation. That can be rain or snow with lower pH, and so a lower pH is acidic. Normal rain has a pH of about 5.6. Acid rain has a pH of about 4.3. So we're not talking about acid falling from the sky that would burn you, but the pH is lowered enough to have some environmental effects. So over here on the right, we see effects. One thing that can happen is that the acid in the precipitation can cause nutrients to leach from plants, from plant leaves, and that ultimately kills those leaves, and then the plants will die as well. So this forest has suffered the effects of acid rain. It's not that acid has burned off the leaves, as you might first predict. It's that over time, so over a long period of time, acid rain has fallen and caused nutrients to leach out of these leaves, and therefore the plants will die because they've lost those nutrients. So obviously that can have devastating effects on that ecosystem. Another thing that happens is that as acid rain falls into bodies of water, those bodies of water can become more and more acidic. And what we see here is, if you look at the left, we have pH 6.5. So if a body of water has a pH of 6.5, which is a close to neutral pH, we can have all of these different species living in that body of water. pH 6.0, we're still okay. But as the pH goes down, the number of organisms that can live at that pH declines. And so what we end up with down here at the far right end is at a pH of 4.0, the only organisms that can live there are frogs. So by changing the pH in bodies of water, you're changing the environment in which organisms live, and therefore not all organisms will survive. And you've already looked at the effects of biodiversity and ecosystem health in previous modules. Looking at the ozone layer depletion, first of all, it's important for you to understand a couple of different layers of the atmosphere. So take a look at this figure on the right. Here's the surface of the Earth on the bottom. The layer of the atmosphere that's closest to us, where our weather occurs, is called the troposphere. All right, so that's the troposphere. The next layer up is called the stratosphere, and that's where the ozone layer is. So the ozone layer is stratospheric ozone. We need that. The ozone layer in the stratosphere is really important. However, if ozone forms down here in the troposphere, that's called tropospheric ozone, and that's part of smog, and we'll talk about that shortly. That's bad. So remember, stratospheric ozone is the ozone layer, and that's good. Tropospheric ozone is close to us, close to the Earth's surface, and that's bad. It causes health effects to humans. So here we're talking about, with this part B here, ozone layer depletion, we're talking about stratospheric ozone, the good layer that we need. So what the ozone layer in the stratosphere does is it absorbs UVB and UVC radiation. And UV radiation causes damage to the DNA in our bodies and can lead to skin cancer, as well as other effects on organisms, including bacteria and eggs of organisms that lay their eggs out in sunlight. So it's the ozone layer, the good thing that it does for us is it blocks UVB and UVC radiation that can be harmful to us. That's why we need it. The ozone layer is naturally produced, and that production is continuous. Now, I'm not going to get into it too much, but basically, UV radiation from the sun reacts with oxygen and leads to the development of 3 oxygens fusing to each other, and that is what ozone is. It's O3. Humans created chemicals called chlorofluorocarbons, or CFCs. These are completely man-made. They do not exist in nature. And humans created these chemicals and tested them, and at least at the surface, they didn't cause any harm to human health or any environmental harm that we could tell. We use chlorofluorocarbons in refrigerants, in fire extinguishers and aerosols, so they are propellants, and also in polystyrene foam. So when they were first created, like I said, no harm seemed to come from them, and so they were really beneficial to people, and so we produced them and put them in a bunch of things.